These are your instructions. In general, you just need to follow the PowerPoint. There are instructions for you in the yellow boxes on each slide. Please make sure the sound is turned up on your device so you can hear the narration. And remember, if a slide asks for homework, don't forget to send it via Show My Homework. If a slide asks for Educate to be completed, don't forget to do it by the date that's given on the slide.
This lesson is all about internal energy and heating. By the end of the lesson, you should know a definition for internal energy. You should be able to describe what happens when a substance changes state and explain how heating changes the energy stored in a system. This is our starter activity. Can you unscramble the words below to see if you can come up with 4 pieces of key vocabulary? Pause the video here while you work on it. Check your answers using this slide. You should have liquid, energy, solid, and particle. You should be aware from our previous work about the structure of particles in solids, liquids, and gases. Particles in a solid vibrate about a fixed position, but they don't move from place to place. However, particles in a liquid can move past each other, and particles in a gas move very quickly and in random directions. Anything that is moving has kinetic energy. So all of these systems have kinetic energy because all of the particles in them are moving. This diagram shows 2 molecules of hydrogen chloride. Particles in a system also have energy because there is energy stored in the forces between the particles. We call these intermolecular forces. If the particles are molecules rather than atoms, then there is also energy stored in the chemical bonds between the atoms. For instance, in this diagram, between the atoms of hydrogen and chlorine. The energy stored in both of these ways is potential energy. The internal energy of a system is the total energy that the particles have in their kinetic and potential energy stores. So that's the energy in both of those stores added together that makes up the internal energy. Now, don't forget, a system for us is just the object or group of objects that we are studying. Heating a system transfers energy to its particles. They gain energy in their kinetic energy stores and start to move faster. This increases the total internal energy. If the substance is heated enough, the particles will have enough energy in their kinetic energy stores to overcome the forces of attraction holding them together. This means you can have a change of state. Now let's have a look at this process in a little bit more detail. If we start with a solid and we put in energy by heating it, we increase its internal energy. At some point, the solid becomes a liquid because the forces holding the atoms or molecules together have been overcome. We call this process melting. If we continue to heat the liquid, we increase its internal energy again. At some point, the liquid becomes a gas, and we call this boiling. If we take our gas and we let it cool down, its internal energy reduces. The gas becomes a liquid again, and we call that condensing. And if we take our liquid and cool that, we decrease the internal energy further, and at some point the liquid becomes a solid again, and we call that freezing. There is also a special case where some materials change from being a solid to being a gas without the step in between of becoming a liquid. This is called sublimation, and an example of this is solid carbon dioxide at room temperature, what is sometimes referred to as dry ice. Now there are a couple of points about changes of state that you need to remember. The first thing is this: mass is conserved during changes of state. This means if you start with a kilogram of solid ice, you melt it by adding energy, you'll end up with a kilogram of liquid water, and if you carry on heating it, you will boil it until you end up with a kilogram of water vapor, a gas. Now, at no stage are you adding any particles or taking any particles away. This means that the mass is the same in each case, and we call this conservation of mass. The second thing is that these changes of state are physical changes. They can be reversed. This means if you start with solid ice, you melt it to get liquid water, you heat that and end up with water vapor, and then you cool everything and reverse the process so you're back to a solid ice. There's no difference between that ice and the ice you started with. They're exactly the same because these are physical changes, not chemical changes. No chemical bonds are being broken. We show the fact that these changes are reversible by using these special arrows. Your final task in this lesson is to take a picture of the work that you've done in this lesson from your book and send it via Show My Homework to Mr. Rahman by Friday the 15th of May.